Dear Professor Teo, my name is Oscar Rios, and this is my video about the last workshop, and the last report about the workshop 15 and 16, about the troubleshooting and out-of-flight control system, okay, in Airbus 320. About the activity number one called troubleshooting and link test and flight plan. And we perform a static leak test on the model with the Garmin GSU 25. We use the Barfield 1811D tester. The data we start at 2000 feet. After 1 minute, and the altitude dropped to 1950 feet. The total leak was 15 feet per minute. The interpretation and the Barfield manual says that tester limit is 100 feet. However, our operational limit for the aircraft system is 20 feet per minute. The result is 15 feet. This is much higher than the limit, therefore, the result is fail. We observe the Garmin 3G3X and display it show a red X and the message ADC fail. This confirm in this case we I simulate this fail the model Garmin has this limit 20 feet per minute. This confirms that ESU is logic is good. It detect and the pressure error we pull the circuit breaker to enter, and the system switches the standby instrument. Okay, about the flight plan. And the second, we analyze the flight plan. We create a route with a Garmin G3X system. We enter using definite waypoints manually. Okay, the system correctly calculate the track, the distance, and the estimate time in route. This verify the internal navigation logic. The flight plan to the autopilot, and the aircraft followed the route on the screen. This confirms the digital interface between the GPS and the flight control computer is working correctly. The system operates within the manufacturer specification for lateral navigation. And activity number two about the auto-flight control system. Uh, we use the Airbus A320 8822 manual was as a reference. Modern aircraft use closed loop system. This means the system needs feedback to correct errors. We analyze five specific control loops. Airspeed loop. This control the auto thrust. It needs data for the pitot 2. If the leak from our first test exit, this loop fail. And altitude loop, this control the pitch. It needs barometric data to stop vertical oscillation. And lateral loop, this control the roll. It use GPS and inertial reference system. And pitch trim loop, this move the stabilizer to correct the center of gravity. And the last one was yaw damper loop. This is very important. It use the yaw rate gyro to stop Dutch roll instability. Okay, the theoretical model matches the real system. The system constantly compares the set point with the feedback. If the sensor data is invalid, like in our leak test, the error calculation is impossible. The result is the autopilot disconnect for safety. This is all. Thank you.